Hello. One way that you can socially isolate yourself is go to a party and start talking about polar coordinates. But polar coordinates are incredibly useful, and so I wanted to give you just a quickie on the skinny of what's going on with polar coordinates. So let's start with a picture of the plane, and we'll just start with the ordinary x and y axes. Pretty familiar. And then we'll take a array, or I guess a line segment, starts at the origin, and the endpoint will reuse the symbols as coordinates x, y. Okay, no big deal. And we can actually draw pictures of what x and y mean. That's what x and y coordinates mean. And then we can kind of fill in another way to do this. And the other way to talk about things is to say, hey, where's Wichita? Well, Wichita is, I don't know how many miles, 900 miles east. So you give a distance and then you give an angle. And that's what we're going to do here. So we're going to take our point that we had called the angle theta, and the distance is r. So those are the polar coordinates of that point, r and theta, and the Cartesian coordinates are x and y, and that's about what's going on. Now, a lot of times when you can't figure out what's going on with some expression is to think of it in terms of polar coordinates. That can be very, very useful in calculus and in physics and in chemistry and in all kinds of other applications. So let's go through quickly how to do the conversion. And one way is pretty straightforward. We can say what the cosine theta and sine of theta are, and there's theta. So the cosine theta is adjacent over hypotenuse, x over r, and the sine is opposite over hypotenuse. So we'll just write those in. And a lot of people find that more useful in this form, where you can just solve for x and y. You have to do it correctly, though, excuse me. So there's how you go. If you know r and theta, you can find out x and y. Going the other way is a little bit more ambiguous because what we know here is by Pythagoras, x squared plus y squared is r squared. So if we have r squared is x squared plus y squared, that gives us a little bit of a dilemma, because do you choose the positive square root or the negative square root when you're trying to get at r? And the answer is yes, both work. And we'll see how that happens. The other thing is that we can't get at theta directly, but we know its tangent is y over x. So we'll just write that in. And that, of course, means that x cannot be 0. That's how I got this scar in 8th grade. So, so the problem here with going from knowing x and y to wanting to know r and theta is you got to make a choice. Tangent is periodic, so you add pi, and you still have the same ratio. And r, we have to take this square root. So there's a simple way to handle this ambiguity, which is this. I'll do a couple of examples. Let's just do r is 4 and theta is 30 degrees. And so I've just drawn in the axes, and so I'm going to make the angle 30 degrees and the distance 4. Bingo. Usually people use radians, but it goes either way. What about the opposite situation? By the opposite, I mean what happens if r equals minus 4 and theta equals 30 degrees. And that's something that could happen if you got some expression for r. You'd have to take the square root, and you don't know whether you got the plus 4 or minus 4. Those are both valid square roots. The answer when r is negative is you go backwards. That's it. So here we go. We're going to go backwards. And so this is where r is minus 4 and theta is 30 degrees. The ambiguity is that that is also where r is 4 and theta is 210 degrees, there's that 180 degree difference, and that's the periodicity of tangent. So you have to make some choices with that. Very quickly, let's look at some equations. There are a couple of real key ones. Some of them are fun, but they're more the three mathematicians bottle of whiskey Saturday night kind of thing. But one thing that's very important is if we look at x is equal to 3, r is equal to 3 cosine theta. So theta is going to go around and r is going to go around like the cosine. So what's going to happen with there? You can get a good idea of what it looks like, but to be specific, what you have to do is convert it to Cartesian coordinates. And in this case, the way you do that is you introduce a factor of r on both sides, and now everything is Cartesian. R squared is x squared plus y squared. 3r cosine theta is just 3x. So you've got x squared plus y squared is equal to 3x, and a little bit of algebra completing the square tells you that's a circle. Center is at 3/2 0, and the radius is 3/2. So it goes through the origin. The other one, which is a little bit more surprising, is what if we take r is equal to 3 secant theta? And so this is one of the most surprising things about polar coordinates, is what these secant, cosecant, inverse things look like. And what we're going to do here is take this thing and say, hey, look, cosine theta is, I probably better look up here. Cosine theta is x over r, so secant theta is r over x. Don't forget the 3. And now the r's cancel. We know r is not 0, so the r's are going to cancel, and what we're left with is 1 is 3 over x, or x is equal to 3. And so this secant is a vertical line. Cosine gives you a circle, secant gives you a vertical line. Stay safe, stay home.